Now we will continue with the PID tuning of the bed and the nozzle. And I also tightened the screw of my bed. I will continue with the PID tune for my bed. But for that, I heated my bed to 100 degree. Right now it's fluctuating to 99 to 100 point something. Yeah, this is pretty normal because the PID tune is not made yet, not applied yet. And by the way, I'm not saying this is the correct way. I just thought that, okay, I will use this printer for the ABS and I will use this one, my heat bed. It's 100 degree most of the time. And I will use my chamber since I want to print ABS, my panels will be closed all the time. So I thought that, okay, this is the condition. And yeah, so and I will also hit the chamber with the bed. So because of these requirements for the ABS, and I heated my bed at 100 degree and waited. As you can see, it's been 20 minutes after it's heated up approximately, and I waited 20 minutes. But yeah, obviously, as you can see, it's the is if you see the nozzles thermistor nozzles is, as you can see, the nozzle heater is not active, but as you can see, the thermistor is reading 50 degree, which means which means my Z is 10 millimeter right now as it recommended. As you can see, my chamber is approximately at 50 degree, which is very good. What I meant, I tried to create the condition which I will use most of the time. So with this condition, I will do my PID tuning. So I'm thinking that, so if I do in that way, my PID tuning, my PID values will be more reliable for my usage. So what I would recommend to you in that logic, what I would recommend to you, for example, maybe you want to print only PLA on your printer. So in that case, it's generally 60 degrees used for the PLA on the bed. So your target degree should be 60 in that case, and you should be doing PID tuning in 60 degree. And also, since PLA is not loving the heated environment, so you want to take your panels, you want to provide the airflow around your print. What I'm trying to say, think about your goals, and with that goals, apply your environment on your printer. After that, do the PID tuning. So I will just, again, I will, of course, following the document. So I will just copy that command. And by the way, before doing that, just you should home your printer, and after that you should go to the middle of your printer, and the Z value should be 5 to 10 millimeter. Once your nozzle is placed on the required place, I'm in the middle of the build print, in the XY axis, and on the 5 to 10 millimeter on the Z axis, run this PID calibration command. So target is 100. I will leave it like that since I will use this printer for the ABS. So most of the time, if you will print PLA, use 60 or 70. It depends on your choice, I can say. But I guess the 60 was the common usage. And yeah, I will just send the command and it will do its thing. So this can take time. Document says can last about 10 minutes. So take a coffee, maybe. Our PID tuning is finished for the heated bed. Now let's hide this one. Yep. And now we need to save the PID values. So for that, we will just send a command which is save under save config. And it's restarting it because we saved the config. Yep. Now for the PID tuning for the heated bed is finished. That was all. Now we will do the PID tuning for the hot end. So for that, it is recommended to use your cooling fan at 25%. So we will do that with this M106S64 command. So after that, we will run the PID calibrate command. It's the you can change this value. This is the target value for the hot end heater, 245 degree. So if you want to tune it for the PLA, you want change this value to 190, or what degree are you using for the PLA? So I will use ABS mostly, like I said. So let's run it. So it will again do the same thing like the heat pad. And yeah, we need to wait until it's finished. Once it's finished, again, we will say save config, and it will do the job and restart the clipper. So if you see your config file at the bottom, you will see the new PID values for the bed and the heater. So now we will continue with the doing quad gantry level again. We will continue with the quad gantry level with the heated chamber. So for that, set your bed to target ABS target 100 degree I'm using, and for the hot end it's recommended 240. I'm also using 240, and also you should be careful about your chamber heat. But since we did PID tuning just before, so our chamber is approximately 50 degree still in there, because I didn't stop the feeding bed. What I am trying to say, just hit your chamber with your heat pad, then after that hit your tool also, then run the quad gantry level. Do this test, I mean. So for that, first I will home again my printer. Oops. Then I will run quad gantry. Yeah, okay. By the way, if you are getting error while you are trying to do this, just just try to manually level your gantry. You don't go, you don't need to go too much and run the macro again. So as you already know, or I don't know, the quad gantry level is basically leveling your gantry according to your bed, which is the beauty of the V2. So this is like actually manual leveling your bed, but in that case, you are trying to level your bed according to your leveling your bed to your tool. But since we have flying gantry and we have probe, inductive sensor, we can automatically do that. We don't have to manually adjust the level gantry or bed. Now it's taking the measurements, and it will it's taking the measurements, and since it has form independent Z motors, it's it's adjusting the gantry level. We also want to test our probe accuracy, since accuracy since our chamber is heated. So you know the heat is affecting your electronics. So normally it shouldn't have 50 degrees shouldn't affect your probe that much, but we should test it, we should see it. Let's see. But first we want to, again I want to go to the middle of my print, and yeah, Z and F. Yeah. Now I will run probe accuracy. Now, and we will see the deviation. Okay, yeah. As you can see, my standard deviation is 0.002958, which is lesser than 0.003. Yeah, if this value is lesser than 0.003, you're good. And yeah, you can also see this. It's not jumping around. It's just a minor changes. Now we will do the Z offset adjustment. This is basically saying your printer to height difference between your bed, the pin which is in the ZN stub. Printers should know that what is the height difference between them, and after that, it, for example, before it's starting, it will, while you are homing, it will hit the ZN stub and it will subtract this value from it, and it will know that okay, the actual bed is in this level, in this Z level, and it will position itself on this specific Z level, and it will start to print. So for that, you need to home your printer and do the quad gantry level. We just did it, so I will pass that, and we will run Z and stop calibrate. See, yeah. No. No, I will abort it because it's saying run bedle mesh clear. Yeah, I think I don't have any mesh data, but yeah, I will just run it. Now I will just run the Z and stop calibrate. So for that, we need a paper. This is like adjusting your Z offset in the normal printer. We will take paper as a reference and we will move our tool head in the Z direction. So we will go down slowly once the nozzle is touching the paper, and this value will be used for the Z offset calibration. But another thing before doing the math, like it's mentioned here, Clipper assumes this process is done while the printer is cold, but we are performing it while it's heated. So that's why it's recommending us to add another minus zero point 0.1. So if, and by the way, to move our nozzle, we will run this test Z command. So test Z equals to -1 if your Z is not too much high from your bed. I would recommend to you use to 0.1. Maybe you will run this command more than you need, but you will be on the safe side. I will use 0.1, and yeah, let's test with the paper. I checked my nozzle. It's really high. I will go to 0 position to make it easier. Z0F something. Yeah, now it's in the 0 position, and I will use test Z equals to -1 because I want to go down, and I will try to find the I will add additional 0.1. I will run test Z for the -0.1 more time. Yeah, now this should be my offset. Now I will type accept to end the macro. Now we want to save the changes, so we will say save config, and it will save the config and it will restart Clipper. Now once it's ready, yeah, I will run my Z to 5 again because I went extra 0.1, not X, Z. Yeah. Yeah, we need to run. home command because it's the firmware is restarted. We can test it. I will run X. I will again drag my toolhead to middle of the printer with the Z10 again, and I will say go to 0 for the Z, and yes, that's what we want. It's now touching the paper. Actually, in my case, it is grabbing the paper. It can be too much, but I will recalibrate it uh, after doing the first layer of the first print. If it is too much, I will just run this command with this sequence again. But for now, at least it is compensating the difference between the pin, the Z pin, and the bed. So right now, that's what we want. So like it says, just fine tuning should be will be done later. We can quickly go through it. We can do with LCD screen if you have. It's in the tune menu on the display. If you don't have the LCD screen, just add these two macro in your config file, restart your firmware, and when you run Z up, or it will move 0.01 up, and for the Z down, when you run Z down, it will go down 0.1, sorry, 0.01. Now we will do the extruder calibration. For that, first I will remove the hot end from the tool head. The reason behind that, because there is a nozzle connected right now, my hot end. And since I want to only calibrate the extruder, we want to free way for the extruder. So because of that, I will basically remove the hot end part from the tool head, and I will run the extruder calibration. Clipper shutting down itself when I unplug the thermistor. So I just remove the hot end and plug back to thermistor wire and the heater wire. So it will not give us any trouble now. Yeah, it's ready. Now I will put my filament and mark it with the 120 millimeter. This this 120 millimeter should be marked from the tool head. So its tool head will be our reference point. We will extrude 100 millimeter filament, but it seems Clipper does not allow extrude more than 50 millimeter, so we will extrude 50 millimeter 2 times. So let's start. It's basically saying that the hot end is not hot enough to extrude, so we will just temporarily change this minimum extrude temperature in our config file to run this test. Okay, min extrude, yeah, it's 170. For now, we will change the min extrude temp to 10 to test it. Yeah, we saved this and restart our firmware. Yeah, now it's ready. Now we should extrude. Yep. I realized that my extruder stepper motor's direction is wrong. When I say extrude, it's actually retracting it, so quickly change it. So extruder direction, we want to inverse it and save it. Again, restart the firmware and let me put the filament again. We will extrude 50. Yeah, now it's extruding. And we will run another 50. Now we will measure how much filament is left from our marked point. Normally it should left 20 millimeter, but in my case it is 21. So we need to recalibrate it. So for that, so we will use this formula. We ask 99 millimeter, and it's the formula is just old value times actual extruded amount divided by target extruded amount. This means old value is in your config file. Like in the formula, I will take the old one, 22.678511 times 99, which is actual extruded amount, divided by 100. So this is my new one. It's oh dang it. It's let me just copy and paste it in here. Marking this. So I will make this one dot. Yeah, now I will I will save it and I will restart the clipper. Yeah, now I will test again with the same method. I will do the same things, same steps. Just check the remaining part. It's 20 millimeter like we expected. Now, if it is not 20 millimeter in your second try, do the same math and change your rotation distance in your config file. Basically do the same steps until you are at the 20 and 20 point something. That was all for the commissioning part. Basically our printer is actually ready to print after, of course, after running the PTFE tube to toolhead. So everything's working. I have a, I can say, fully functional Voron v2.4. I'm pretty happy. Let me know also what is your progress in your Vorons in the comments. And anytime feel free to ask. You can subscribe my channel if you want. And yeah, see you on the next one.